Hello everybody. This workshop has two main goals. The first one is to show the differences between the trial lens and the final lens delivered to the patient. And the second one is to demonstrate the effect of the tilt of the trial lens on the optical power and to understand what is the task of the designer. So we are here in the refraction room, and classically, eye care professionals are using either a refractometer or the trial lens device or the photometer. All these different devices are used on axis situation. That means that the visual axis of the eye is fully aligned with the optical axis of the device. We are now going to concentrate on the trial lens device. This trial lens is purely spherical, biconvex or biconcave, and this trial lens is used centered in front of the eye without any tilt in front of the optical axis of the eye. On the other hand, the final lens delivered to the patient is different in terms of curve, and in front of the eye, with a different tilt, the conditions of wear are completely different compared to the zero tilt of the trial lens. We are now going to demonstrate the effect of the tilt of the trial lens on the optical power, and for that, we are going to use this photometer. And as a first step, we are going to put the trial lens on the nozzle of the photometer in the standard position and centered on the nozzle, perpendicular to the optical axis of the photometer. We can check that the displayed value of the power is in conformity with this trial lens, and in this case, the trial lens is a +4 diopter. Now let's see what happens when you are tilting the trial lens in front of the nozzle of the photometer. We can discover that the optical power displayed by the photometer are changed, that we are creating oblique astigmatism. In fact, the tilt of the lens is breaking the good focus of the emerging beam and is producing aberrations that can be greater than 0.25 diopter and be even greater according to the refraction value. In order to see more in detail the correlation between tilt and aberrations level, this is an animated slide showing a progressive tilt of the +4 trial lens from 0 degree to 20 degrees and corresponding power error and astigmatism. We understand now why differences between trial lens and final lens delivered to the patient are so critical, and why the designer has to transpose the room refraction value of the trial lens during final lens creation, taking into account the real condition of wear. So, to conclude, we have to remember three main facts. First, the refraction room conditions on axis are different from real-life condition of wear. Second, trial lens is different from a final delivered lens with different curve and mainly different condition of wear. And at last, the tilt of the lens is impacting the optical correction, producing significant power error and oblique astigmatism. And designers have to take it into account during the optical calculation, producing a lens with complex optical surfaces.